This video should be fairly short. I could certainly go into a lot of detail and show several examples, but I think one example we'll have to do here. So we have here is what's called a piecewise function. Sometimes called a piecewise defined function. I think I've seen them called compound functions before. What we call, of course, doesn't matter. The idea behind the piecewise function is that we've taken the domain of the function and divided it into pieces. And there can be quite a few pieces. There are these things called step functions, where actually it's divided into an infinite number of pieces. This one is just broken up into two different pieces. So the domain is all real numbers. We always assume the domain is as big as possible. So if we start with all the real numbers and take all the real numbers that are less than 2, that's the first half of the domain. And then we also have all the numbers that are bigger than 2. And there's a change at 2 itself. And I'll come back and look at that after we've talked about this a bit more. So if you're trying to evaluate the function, say you want to evaluate f of -1, well, you look up here and say, well, -1 is less than 2. And so we're going to use the definition up here that says that in that case we square the input to get the output. So f of -1 is the square of -1. Square of -1 is 1. In the same way, f of 0 would be 0 because 0 squared is 0. If we were looking at f of 1.999, you would square 1.999, which is, of course, going to take you pretty close to 4, just a bit shy of 4. Now, on the other hand, if you take a number bigger than 2, let's say 5, f of 5, well, we're going to use the second part of the definition of the function given here, the 2x plus 1. So we take 2 times 5, 10. 10 plus 1 is 11. So the value of the function at 5 is 11. And likewise, if we're calculating f of 4 or f of 3 or f of any number which is bigger than 2, even 2.1, f of 2.1 would be 2 times 2.1, 4.2 plus 1, which would be 5.2. Now, if we look at the graph of that, so I'm going to change the screen share here to look at our good friend GeoGebra. Now, to input this into the GeoGebra program, there might be some other way of doing it, but the way I did this is put in two functions here, y equals x squared, and then I put in parentheses next to that x is less than 2. And I think what this does is as long as x is less than 2, it gives you x squared, and if x is greater than 2, it multiplies that by 0, and then you end up with the function just being 0 there. So it's the green curve here. The actual function is both the green curve you see here, and its continuation with this orange line. The two of them together are the total function. Down here on the x-axis, we have some extra stuff which I can't really get rid of. It's just that the green function was taken down to 0 and continued out here, and the orange function was 0 for everything less than 2. But that's not actually part of the graph. It's just part of the way this computer is creating the graph. If I were creating it on paper, I would not have the orange part here or the green part here, and if I were coloring it, I would color it all the same color because it's really just one function. Now, piecewise functions can be continuous, or they could be discontinuous. This one's discontinuous. It's broken here. The function is decreasing from -infinity all the way up to 0. So on the interval from -infinity to 0, it's a decreasing function on that open interval. And then it's increasing, but broken on the interval from 0 to infinity. It will continue to go up here. So we looked at f of 5, for example. Well, here's 5 on the x-axis. If we go up here, we find the corresponding value, as I said, is 11. F of 0 is here. F of -1 is 1, like I said here. The biggest question comes here at 2. Well, if you plug 2 in, do you get 4, which is the endpoint of the green curve here? Or do you get 5, which is the left endpoint of the orange line? Well, it depends on how your function is set up. So if we go back and look at the definition of the function again, which is, there we go, okay. Well, we can see here that f of 2, I think I'll actually need to do a new share if I want to show that. Okay, so f of 2, well, f of 2, well, is 2 less than or equal to 2, or is 2 greater than 2? Well, 2 is equal to 2, so we'd go here. So f of 2 is going to be 2 squared, or 4. Just throw that in here. F of 2 is equal to 2 squared equals 4. Because of this little line under the less than sign. If the line had been under the greater than sign here, then we'd have x is greater than or equal to 2. Then in that case, f of 2 would actually be 2 times 2 plus 1, it would be 5. Now if we go back and look at the graph again, go back to the GeoGebra, where is it? There we go, okay. So what you'll typically see in a graph is a way of indicating the point. So what's real common here is to have an open circle at the end of the orange line and a filled in circle at the end of the green parabola-like object. It's paraboloid. It's a parabola up into this point here, and then suddenly it just stops. I don't, well, let's see, I probably could actually add those to this tools. I can certainly put points here. So if I wanted to try to indicate that, one way of doing that might be to go ahead and the points seem to show up down there. Well, maybe I can't do it. Oh, there we go. So something like that. Whether it's possible to make an open looking point here, it's probably possible. I'm just not going to waste your valuable time messing around with the program here. Okay, so that's, like I said, a short video for this one, and more to follow.